Hello Anushka, is my screen visible?
Yes, Tejas, it is.
Okay, fine. Okay, fine. Now we will be starting with our webinar. Uh, Please, team coordinators, please tell if is it clear or we can start with it now.
Yeah, we can start with it.
All right.
Please do not draw on the screen.
Mama, Mama,
Very good evening, everyone. I am Tejas, founder of Exploring the Cosmos, a science group. This group deals with the cheerful interaction of members on many science topics, mainly about astrophysics and general sciences. You all are welcome in this webinar on the theme, The Game of Energy, and we hope you will engage your kind interest to our lecturer, Miss Anushka here. This is also to inform you that if you have any query, any suggestion, you can write directly to admins or coordinators, which you can see on the chat box here. And you are advised not to create nuisance here. Okay.
hello Tejas, could you please be louder? Please repeat.
Okay. All right. Very good evening, everyone. I am Tejas, founder of Exploring the Cosmos, a science group. This group deals with the cheerful interaction of members on many science topics, mainly about astrophysics and general sciences. You all are welcome in this webinar on the theme, The Game of Energy. And we hope you will engage your kind interest to our lecture here.
Hey everyone, this is Shivansh, our team coordinator, welcomes you all here. So, our speaker is Miss Anushka. She is our friend and she is more into writing her understanding on cosmology and have written many outstanding articles.
Hello, I am Akash, a member of here. Anushka will be talking about the game of energy, and I hope we can keep you engaged for the rest of the webinar. Thank you.
Anushka, can you wait for some time?
Yes, that's fine.
I have to open the PowerPoint presentation.
All right.
Okay, yes, Anushka, all right. You can continue with your work. Hello.
Hello, everyone. It's me, Anushka Sharad, your speaker for today. Am I clear, everyone? Tejas?
Yes, you are clear.
Yes. So I welcome you all on today's webinar, which is about the game of energy. So are you all excited for today? I hope you are.
Yes.
Let's begin. So have you all ever wondered that what is energy? Do you think it's an abstract noun? What would be the energy? So yes, this is our topic for today. What is energy? I'll begin from the basic. It is the most powerful and useful concept, something that makes things work. You might have studied energy in your high school or in your colleges, lots of theories, lots of questions about it. But today, I will drive you beyond. Something else will be today. Hello, Tejas. Is my video visible?
Uh, yes, on the Zoom you are visible, but on live stream you are not visible.
Uh, just a minute.
Can you ask that lady to confirm that what happened?
We couldn't do that. What you could do is turn off PPT while I speak. Is it possible?
Yes, it is possible, but it might not be convenient for your assignment. You know.
Take it when I'm starting with the new subtopic. You put on the PPT.
All right.
You might turn it off now. So yes, as our avid participants are already aware about today's topic, that's the game of energy. We are coming through some glitches. Please hold on. I'm sorry for the disturbance to everyone.
Your video is not visible, Anushka. Yes, it is now.
Hello? Is it visible now?
Yes.
Any other problems?
No.
All right. So, yes, mostly energy is defined as ability to do work, isn't it? But today we will be driving this session beyond. Energy is the most powerful and useful concept, something that makes things work, isn't it? So in today's webinar, we will discuss about energy in conceivable manner. I will try, or my motive is to explain you energy of the universe, of the cosmos, so that you will be able to grasp it easily, to perceive it in the way I am explaining you. Okay. So energy couldn't be seen, right? Have you ever seen energy? It's like the air. At least you can feel the air, but energy, you can neither feel it, maybe you feel it, but we can understand that energy is working by understanding or by looking at the things it makes behave. And the most common energies, is that potential energy, kinetic energy, heat, light, mechanical, electromagnetic energies, etc. Today, we will be talking about the energy in the universe. Okay, so the energy flows on the earth are embedded in the energy flows in the universe. Are you getting my point? The energy that flows on earth is embedded in the energy that flows in the universe. A delicate balance among gravitation, nuclear reactions, radiation keeps the energy from flowing too fast. Is my video visible?
No, Anushka, your video is not visible. Can you recheck it? What has happened actually?
Was
Yes, it
my
is
audio
now.
clear till now?
Yes, your audio was clear, but video was not clear.
Oh, fine. Hello?
Yes, you are audible. Please
You're
continue.
audible.
Yes, all right, got it. So now here we finished about telling you what is energy. You understood it. We know basics of energy, that is potential, kinetic, heat, magnetic, electromagnetic energies, and the energy that flows on the earth is embedded in the energy that flows in the universe. All right. A balance is made among gravitation, nuclear reactions, and radiation to keep energy flowing too fast. Is it clear? So now let's move forward and I will explain you about where is energy present. So there is abundant energy in space. I hope you agree with this point. There is abundant energy in space. Planets, asteroids, and moons reflect that energy back, glowing in the darkness. That's how we get to know that energy is present in some amount. The planets or the stars can release energy by themselves in the form of heat from volcanoes or other such processes. So, virtually everything in space is in motion. You agree with this point? Yes. So, there is also kinetic or motion energy in space. Now, in your high schools or colleges, you might have definitely learned or solved questions or equations about difference between kinetic energy, potential energy, how they transform from one form to another form, etc. All right. So, as we have studied enough about kinetic and potential energy in high school and colleges, today we will dive deeper into universe and I will enlighten you about dark energy, theory of relativity, and E is equal to mc square, the mind-bending formula by Einstein. Let me ensure, please hold on.
Yes, Anushka, you can continue with your.
I don't know, a glitch is occurring in the between. So yes, as I have mentioned earlier about the topics we are going to discuss. So first, let us understand the energy flow in the universe. All right. So the forms of energy we have considered include electromagnetic radiation, magnetic fields, cosmic rays, gravitational energy, and gravitational radiation. Dark matter and vacuum energy, one of the most important in the universe and in the physics we study. So the energy flow in the universe is a spontaneous process. Energy flow in the universe is a spontaneous gradual process. So this implies the continuous increase of entropy of the universe. Now you might wonder, what is entropy? Have you ever heard about this term? I doubt you haven't. So the entropy is the deterioration. By that I mean entropy is the lack of continuity. Entropy is not energy. Entropy is how the energy in the universe is distributed. Are you getting me? I am trying to make these processes, these concepts very clear to you. Please listen to me carefully. Entropy is not energy, it is the way that how energy is distributed in the universe. All right, so there is a constant amount of energy in the universe, but the way it is distributed is always changing. Let me give you an example. Consider one particle has all the energy in the universe and the rest have none. Or to another example, that most particles have an average amount of energy or average amount of force. So we can say that entropy increases. And the way energy is distributed is based on the entropy. All right. So energy may flow in the various forms throughout the universe. Potential energy is converted into kinetic energy in case of free fall of a body. You might have learned this, I am sure about it, in 8th or ninth grade. So the energy transfer may occur through various thermodynamic processes. That's a different part. Let's not go into that. So the reversible and irreversible reactions occurring throughout the universe. That is based on the energy that particular thing possess. All right. So do you ever think about or do you know amount of energy present in the universe? Think about it. Let me know it in comment section or in the Zoom chat. What is the total amount of energy present in the universe? A simple question? Maybe. Yes, here I have a comment. Gia says it's 0. Well, any other answer? Amount of energy present in the universe. And I have got another answer that is 98%. Yes, I'm waiting for more answers. What would be the total energy present in the universe? Now I can see many scholar students have joined this session. Some say it's 100%, some say it's not detected, and the smartest one says the energy is 0. Well, I appreciate them. The total energy present in the universe is exactly 0. Completely 0. And what would be the source of energy? Like from when the thing started? So you might be knowing things started from Big Bang. All these energies, galaxies, stars, planets, it has begun from Big Bang. That was the major source of energy. I'm gonna tell you more, don't worry. So I will explain you how the energy in the universe is zero. Okay, it is a hypothesis. It says that energy travels from one form to another, isn't it? And the amount or the total amount of positive energy in the form of matter, the amount of positive energy in the form of matter is exactly cancelled out by its negative energy. It's like plus 1 minus 1, answer it gives you 0. Similarly, the amount of positive energy in the form of matter is exactly cancelled out by its negative energy in the form of gravity. That's it. Some students already got my word, some of you might have not. It's fine. So let me explain you again, probably the last time. The total energy present in the universe is constant. By constant, I mean that the total energy present in the universe is exactly zero, because the amount of positive energy in the form of matter is exactly cancelled out by its negative energy in form of gravity. Now you might be wondering, how is energy related to gravity? Isn't it? How is energy related to gravity? Do you have any answer about it? A simple statement or a one word answer? Mass? Yes, I'm waiting for more. Now, you know this, that gravity causes objects to move towards one another, isn't it? And in the absence of other forces, gravity is much weaker than other forces. You must know this. Gravity is present on the earth, and we cannot consider gravity as one of the most powerful or important forces. There are many out there. So, in outer space, it is the only one of the four that can act over scales larger than the solar system. Our solar system is extremely huge, but there are another forces except gravity that can act on the places that are huge than our own solar system. Okay, so it is a long range of force, and it always causes attraction between objects. I don't think there's much about explaining about gravity, as you might have already studied it earlier. So yes, the stronger the effect of gravitational force and the higher the velocities achieved by the particles is how we explain the relation between energy and gravity. The heavier the masses are involved, or the closer they are, or the closest mass are, the stronger the effect of gravitational force and the higher the velocity achieved by the particles. It's a simple thing to understand. Since gravity is limited, or is it unlimited? What do you think? Is gravity limited or unlimited? Yes, I'm waiting for your answers. Think about it. You are not here in this webinar or in this session just to listen all those things I'm uttering right now. If you have chosen to attend my webinar, I hope you know some basics. Is gravity limited or unlimited? Yes, Zoom chat, I'm waiting for you to pop out. YouTube comments. Yes, is it limited or unlimited? Somebody says it's infinite range. For few, it's limited for few objects. Now I can see the controversy. If you are not sure, is gravity limited or unlimited? Think about it. You have your time. Limited or unlimited? I guess it's 50-50. All right. Last three comments. All right. Now, let me take off the curtain from this topic. The gravity present in the universe is unlimited. The gravity is unlimited. So, as the gravity is unlimited, can we use it as an infinite energy source? Think about it. Now, as I've told you, the gravity is unlimited. So, can we use it as an infinite energy source? Can we? Now, let me tell you that gravity is a force. You know this. Gravity is a force and energy is not a force. Energy is energy. Let me differentiate it between it. So, let me be strict about this topic. The gravity cannot be used as an infinite energy source because gravity itself cannot be used as an energy source. All right. So please don't confuse between force with energy. All right. Force and energy is entirely different. Energy is a property of objects such as atoms, things, balls, masses. Okay. And in contrast, forces describe the interaction between objects. Are you getting me? The most simplest or common definition of energy is that ability to do work. But force is exerted on an object. Force is not the ability, it's the exertion. So energy is property of objects and forces describe the interaction between objects. You must note these points. All right. So forces are the way that energy is transferred from one object to another when they interact. Suppose I hit a punch to somebody. I hit a punch to somebody's face. So the energy in my fist, will be transformed on the face of that person when I hit him. Do you get that? I think the video is lagging. Let me explain you again. This is my fist. I have energy in my hand. All right. And I am applying energy to somebody's face. Suppose I want to hit here. So I take this energy and hit here. So the energy in this hand immediately transforms on this hand of mine. Have you gotten me clear? So there's difference between energy and force. Let me demonstrate another example, but after explaining you another concept. So forces are the way that energy is transformed from one object to another. And gravity itself is a force. So it just provides one way for objects to exchange and transform energy to different states. So have you got this interrelation between gravity and energy? Forces are the way that energy is transferred from one object to another when they interact together. But forces are not the energy. Gravity is a force itself, so it just provides one way for objects to exchange and transform energy to different states. I hope this topic is made clear by me. So now, is it true that gravity is unlimited? Again, back to the same topic. In the sense, it never turns off. So the Earth's gravity will never go away. You must know this. The Earth's gravity will never go away as long as it has mass. But since this is just a force and not an energy, the never-ending nature of gravity cannot be used. The never-ending source or the never-ending property of gravity cannot be used to extract infinite energy or any type of energy for matter, any kind of matter. So now, let me demonstrate another example for you. Just hold on for a minute. Yes, can you see me clearly, everyone? Tejas?
Yes, you are
Yes.
audible and visible.
All right. Now I'm going to explain you how gravity and how force will be interacting. Now, think of this rubber band as, can you see this rubber band in my hand?
Yes, we can.
All right. Hold on. Can this rubber band move on its own? Can the rubber band move on its own? No, exactly. So when I stretch the rubber band, it gets stretched. I apply force on this rubber band, isn't it? And when I unstretch it, like suppose I'm leaving from one end, now I have this stores potential energy. When I leave its one end, it hits back and you see its kinetic energy. This is the common example, but I hope you understand what I want to convey. One more time. When I stretch the rubber band, it has stored its potential energy. And when I release it from one end, it changes into kinetic energy, isn't it? Can rubber band stretch or move on its own? No. I am the one who applies force on this rubber band. When I release it from one end, it has potential energy stored in it. When I release it from one end, it gets its kinetic energy. Am I right? Am I right or no? Or is it opposite? Now it has kinetic energy. When I release, it has potential energy. Which one is right? Potential and kinetic, or kinetic and then potential. Yes, yes, I am waiting. Exactly. This has stored its potential energy. When I release, it has its kinetic energy. And we are done with this example. Thank you for triggering your brain once again. Now, let's move towards more interesting part of this topic. That is about dark energy. Have you all heard about this term earlier? Dark energy. Please tell me, have you or have you not? What is dark energy? Yes? Any responses? Have you heard about dark energy? I cannot see any comments on YouTube. I'm waiting. See, there is difference between black hole and dark energy. Please don't mess up between them. Well, the chat is getting flooded with the comments. Let's see what people has to say. Okay, let me explain. What is dark energy? Tejas, you might stop the PPT.
All right.
Yes, I read some Ashmita's comment. She says that mostly it's dark energy and dark matter that covers the universe. Yes, Ashmita, you're right. So let me explain you the dark energy. This is the mysterious part of this session. Hold on for a minute. So ones who cannot hear me clearly, please check out your internet connection. According to me, I am clear and proper. So yes, me, you, my coordinators, this session, our planet, other planets in our solar system, all the matter in space, all the known matter and all apparently unknown matter in the space represents merely dash part of the universe. Fill in the blank. Our solar system, all the whole universe, the known part of whole universe represents how much percentage out of 100%. Consider whole universe as 100% and known universe. How much percentage is contributed to known universe? Yes, very less. That's right. But can you estimate the exact percentage of the known universe? 0.1 is the wrong answer. Keep thinking, go beyond. Trigger your brain. Think more. And somebody says it's 5%. 99% is the wrong answer. It's fine if you give wrong answer. I'm here to explain. You're mean to estimate the right answer, or if you know, you can say the right answer. All right. You, me, this session, planets, known universe, our whole solar system, Andromeda galaxy, another galaxies, or the whole known universe represents mere 4 to 5 percentage of whole universe. If we consider whole universe, including unknown things, whole universe is 100%, and what we know, or I'm not saying observable universe, I am saying known parts of the universe. We haven't observed Andromeda or another galaxies closely, but we know it exists. I am talking about all the things we can see, though via telescope or things. All we know, all we have discovered so far is merely 4 to 5% of the known universe. All right, merely 4 to 5% of the universe. So can you think about what is accommodating 95 to 96% of whole universe if we are just the 4 or 5% of it? Think about it. Dark matter, yes, quite close. Dark energy, the answer, expected answer. So yes, let me take off the curtain again. I like giving surprises. You might have noticed it already. So yes, the rest of the things, a better word for it is that is dark. 23%, I repeat, 23% is dark matter and 73% is the dark energy. Now here I have told you exact numbers, but on different platforms or on different things, these numbers might vary, this percentage might vary. So let's consider known universe or observable universe and then known universe as 4 to 5%, dark matter as 23 to 24%, and dark energy as 73%. You might proceed or succeed there. So this is how. Now you might be thinking, what the hell is this dark energy? Sound or its name sounds mysterious, right? All right, let me explain you further. And yes, please do not mess up between dark energy and dark matter. They are entirely different things. All right. So yes, dark matter slows the expansion of universe. Dark matter slows the expansion of universe whereas dark energy speeds it up. Can you see the huge difference between them? Dark matter slows down the expansion of universe, whereas dark energy speeds up the expansion of universe, isn't it? So if the total energy of our universe is increasing during the universe expansion, the dark energy could be regarded as pressureless because dark energy speeds it up, dark matter slows down, right? Understand this, make it understandable. So yes, the dark matter
You are muted.
Anushka, you are not audible. Please open your camera and mic.
Hello, Anil.
Yes, you are audible.
Hello, am I audible now?
Yes, Anushka, you are audible now.
My mic was mute in between, so yes, I have to explain those things again. Yes, we are talking about the dark matter. Yes, dark matter works like an attractive force. It works like a cosmic cement that helps to hold down all the galaxies or all the planets together. All right, why? You might be wondering why. So the dark matter interacts with gravity. Dark matter interacts with gravity, but it does not reflect or absorb or emit light. That is the reason it is called as dark. We know it is present there. It is present in the outer universe, but we cannot detect it because it doesn't emit, reflect, or absorb light. All right. So meanwhile, dark energy is repulsive. Dark energy is repulsive. It is a sort of anti-gravity. It is opposite of dark matter that drives universe ever accelerating expansion. Universe keeps expanding because of dark energy. Now, dark energy is very dominant kind of force. All right, it is accounting roughly 68% of the universe, of the outer universe. All right, and dark matter makes up to 27%. This is the recent search. The percentage I told you back then was the previous research, and now the percentage I'm telling you is the recent research. And another things, observable universe or the known universe is where we live, is what we know, that is considered as 5%. This is all the regular matter we interact with, and it is every day, especially for students or members or people like me. Now, talking about dark matter and dark energy, more is unknown than known. Do you see the contradictory statement here? More is unknown than known. So, all right, the dark energy we see is because of universe's expansion. Other than that, it is a complete mystery. We are still working on it. By we, I mean the scientists of our country or scientists of this whole world are working on to find how to detect or how to explain dark energy in more conceivable manner. As I said earlier, dark matter makes up upon around 27%. I'm using the word around because we cannot estimate the exact percentage of dark matter or dark energy. All right. So everything you see, everything observed with instruments or with normal or the normal matter we see adds up to 5%. I'm repeating this again. So we shouldn't call it all normal. There is so much more to see, so much more to discover, and we are fraction of it, a very mere smallest part of it. And we are moving closer towards our model. But before that, you need to understand dark matter clearly. So the first point I would like to initiate here is that dark. Hold on to the word dark. Yes, by dark I mean that it is not just stars or planets or black holes that we can see. Observations shows that it's far too little visible matter we can see that makes up 27% of required observations, that is dark matter. The second thing is that it is not the form of dark clouds we might estimate, or it is not any normal matter. Matter is made up of particles called baryons. This is a question of general knowledge, I think. It is constituted of, it is made up of baryons. All right. So we know this because we would be able to detect baryonic clouds by their absorption of radiation passing through them. But we still cannot estimate all the things clearly. The third thing I would like to elaborate is that dark matter is not antimatter. Now, antimatter is entirely a different thing. So we do not see gamma rays. We can detect the gamma rays, but we cannot see those gamma rays and that are produced with antimatter annihilates with matter. So we can rule out large galaxy-sized black holes on the basis of how many gravitational lenses we see. High concentration of matter bend light passing near them from objects further away, but we do not see enough lensing events to suggest that such objects to make up the required 25% dark matter contribution. Now, as I have used the word gravitational lensing, I will explain you about that too with a physical explanation, with a physical model. So, about 1/4 of the universe consists of dark matter, that is 25 to 27%. It ranges between that. The question is antimatter real? Yes, it is. So yes, which releases no detectable energy. The 1/4 doesn't release any energy. So the gravitational pull on all the visible matter is in the universe. Now the most simplest parts of dark matter. Understand it clearly. First, dark matter is dark, but we cannot consider it as black holes or any unknown things. It emits no light, so that's the reason we cannot detect it, and it is not seen directly. But it can be anything. We have not made that research yet. Dark matter is not clouds or it's not normal matter, or the clouds are not made up of normal matter. Normal matter particles are called baryons. If dark matter were composed of baryons, it would be detectable. All right. So the dark matter is not antimatter. Antimatter annihilates. To annihilate means to destroy. Antimatter annihilates matter on contact, producing gamma rays. Astronomers cannot detect gamma rays. Astronomers are not able to detect baryons. So we are still wondering, what is dark matter composed of? And yes, dark matter is not black holes. Please don't assume that dark matter is black hole or black holes consist of dark matter. That's the wrong assumption. Black holes are gravity lenses. Black holes absorb the light. Black holes emit the light, but light cannot go through the black hole. Understand the differences between these concepts. When a light has to pass through black hole, it cannot go through black hole. Suppose, consider my fist, my hand, this hand as black hole and this as light. So due to the effect of black hole, the light going from here will not go through the black hole, it will bend. It will bend this way and go here. Any kind of light cannot go through black hole. I didn't say go in the black hole. I said cannot go through the black hole. There is difference between these things.
Anushka, please switch your mic on. You are not audible.
Hello, Tejas. I said that please put on the PPT. I am having some network issue. I'll be back in a minute.
Okay, all right.
Hello.
Yes, Anushka.
Yes. So back to the thing. Yes, I said as light bends, either light goes in the black hole and that light cannot escape, or due to the gravity of black hole, that line bends. Some part of light will go here, that will emerge in the black hole. Some part of light that is away will, because of the effect of the black hole, because of the dense gravity of black hole, that light will bend. So yes, we are moving towards the next topic. Are energy and theory of relativity related? This is one of the most mind-bending equation or mind-bending theory by Einstein. And now we are moving towards greatness. So let me explain you step by step. In general relativity, scientists say that, or scientists claim that, the accelerated expansion of the universe by introducing a mysterious form of matter called dark energy. We have discussed about dark matter and dark energy, and now we are again on the part of dark energy. That is the simplest form of which may be a cosmological constant whose density is constant in space and time. Could be explained. So we are talking about the alternatives to cosmological constant, which explain the accelerated expansion by modifying the law of gravity, that is widely considered of dark energy. I am going to talk about chameleon theory. I am sure you haven't heard about it. The chameleon theory. So you know this organism chameleon, it changes its nature, it changes itself according to the nature, according to the environment behind. Similarly, scientists have proposed the chameleon theory because in their words they mean to say that a kind of gravity that will change its behavior according to the environment. That is chameleon theory. It is an alternative to general relativity. General relativity deals with spinning of planets, slowing down or accelerating motion, and but gravity or general relativity is considered as cosmological constant. And now we are going to talk about chameleon theory. As I said, chameleons, the organisms, change their cells, change their nature in order to fit in the outer nature. Similarly, that chameleon theory could be used in order to find an alternative for theory of general relativity that will be explaining formation of structures in the universe. It might also be helpful for further understanding of dark energy, that is a mysterious substance or mysterious kind of thing we that is helping the accelerating or expansion of the rate of the universe. So the chameleon theory allows for the laws of gravity to be modified. Okay, we will be testing gravity based on the properties of another planets or based on the properties of another systems or galaxies. So chameleon theory will allow us to modify itself so we can test the effect of changes in gravity on galaxy formation. So the new chameleon theory has the potential to become an alternate theory for gravity, working alongside Einstein's theory of relativity. Okay, so now the curvature of space-time, another interesting thing. Curvature is a simple word. Curvature is the curve. Okay, so the planets in our solar system exert the curve. There is a curve. There is a curvature of space-time explained by the theory of general relativity. So the theory predicts that anything moving through a gravitational field is undistributed by other force follow a curved path. Anything that goes through a gravitational field follows a curved path. As I explained earlier, if there is a black hole, either light will go in it or light will bend by it. Similarly, there is a curvature of space-time that lies in the general relativity. Now, here is coming your model. You need to hold on for a minute. There is something interesting I want to show you. So, hello everyone. Can you see this model?
Your camera is off.
Check from another device. I am using another device. Can you see this black thing? Hello?
Yes, Anushka, your camera is off. Please switch it on.
Can you see it now?
Your network bandwidth is low. Please check your internet connection.
Can you see me now?
Yes, we can.
I am trying to show you all something. See, can you see this black thing?
Yes,
I cannot hear you. Please reply me. Can you see this thing in my hand? Now hold on. Now as you can see this, consider this black thing as space. See, consider this black thing as space and this yellow color thing as the sun. Can you see that?
yes,
Yes.
yes.
Now, as you can see this black thing as the space and this yellow thing as the sun, I have placed in it and that makes the curvature. Consider this small steel thing as the planet, and due to the curvature of space-time, these planets move round and round due to the influence of the gravity, due to the influence of the gravity of the sun. So, was that clear? I couldn't demonstrate it properly. I'm sorry for that. There is some constant problem I'm facing. Hello? All I'm trying to say is that there is a curvature in space-time and the sun in our space, the sun in our solar system and other planets are getting influenced by that sun. All right. So now let's move on towards next topic, that is E is equal to mc square. Another great thing, another greater formula or a greater theory by Einstein. So let me explain you clearly and basic things. E stands for energy. Another side, that is left hand side of the equation, m stands for mass, and c square, that is speed of light squared. Energy equals mass into speed of light squared. So even when masses are at the rest, they have energy inherent in them. There is some kind of energy, some part of energy stored in them. So you have learned about all the energies, including mechanical energy, chemical energy, electrical energy, as well as kinetic energy. So these all energies are inherent in moving or reacting objects. And these forms of energy can be used to do work, such as run some things, or movement of planets, etc. So there is regular mass and there is energy. So Einstein explains that energy is inherent to all those things. A tremendous amount of energy is influenced by mass into speed of light squared. This carries with a tremendous implication that gravitation, which works between any two masses, is the universe picture. So the objects should also work when they are not moving. And that is how Einstein wants to conclude, or Einstein wants to explain, that energy is equal to mass into speed of light squared. That is the tremendous amount of energy. Okay, am I clear about this topic?
Yes, you are.
Yes. So yes, this is how I have finished. Anything else? Now I am waiting for the questions. Interesting questions from all of you.
Yes, it is now Q&A session, and people who are interested in writing questions from and hearing answers from Anushka and other team coordinators can write freely in the chat box. And we have our Facebook team also. We are live streaming live on Facebook also. Anushka and Akash will be answering questions from
Tejas,
Facebook
please
stream
be
also.
loud. I cannot hear you.
I was saying that Q&A session has been started, and those who are interested in Q&A session can write their questions in chat box. And we have Facebook team with us also. We are streaming live on Facebook also, and there are many questions which I observed in the chat
Right, right.
stream of the Facebook. So we will be answering soon.
All right.
Okay, so Anushka, you can start from Zoom chat box. There are many questions which you can also answer.
All right. Yes, I have noticed that there are many questions, but most frequent and the best questions would be answered as we are running out of time.
Yes, I will be asking you the questions. Is that okay?
Who is
Yes,
it?
all right.
Akash. Yes, fine. Please move on.
Okay, so the first question is from B. Shanmukh. He says that gravity works as a product of masses, which is a form of energy. So if the total energy of the universe is constant, so shouldn't gravity be a limited one?
Please repeat the question. Your voice was lagging.
Gravity works as a product of masses, which is a form of energy. So if the total energy of the universe is constant, so shouldn't gravity be a limited one?
All right. See, gravity and energy are entirely different things. So we cannot concord them together, cannot conclude them together that if energy is infinite, then gravity should be either limited or should be infinite. All right. Are you getting me? Gravity acts on the objects. Energy is stored between the objects. We cannot expect gravity to be limited. All right.
Okay. So the next question is also from B. Shanmukh. Wouldn't gravity change into electromagnetic force during the small mass interactions?
I would like to ask him what is electromagnetic force? Is he clear about electromagnetic force?
Can Shanmukh type in the chat?
Until he types, we can move towards next question.
Okay.
Make sure that you take in best questions and take different questions from different people and not from the same one.
Yeah. So the next question is from Gurjinder Singh. His question is, but how we know there is exactly this percent of dark matter and this percent of dark energy?
Yes, that's a great question. That is one of the greatest mystery, as I have mentioned earlier. But now let me explain you with one more thing. Hold on. Suppose this is matter. Consider my hand as matter. And if I flash a light from it, some part of light would hit my hand. Remaining part of light will go above my hand, will go from beneath my hand. So this is how we detect. The part which we cannot detect is considered as dark matter and dark energy. And what we can see under the visible light, consider my hand. That is we consider as known universe or observable universe. But what we cannot detect is determined as dark matter or dark energy because it doesn't absorb, reflects, or emits light. Yes, next question.
So the next question is, how does the idea of dark matter being in existence occurred?
All right, that's a great question. See, that's as I have told about gravitational lensing, astronomers or scientists detected that we have not seen all the parts of the universe. There are some hurdles in between. And that's how they thought about this dark matter and dark energy, that everything is not being seen by us. Something is hidden, something is unknown. And that is how they named it dark matter or dark energy, based on the properties as I have already explained about it. And listen, I tried my best to summarize all these topics in short in today's session. It took 10 to 22 lots of years for scientists or astronomers to make difference between them or to invent this or to discover such things. All right. So if you're willing to know more, if you want to satisfy your curiosity, keep exploring. Yes, another question.
Yeah. So Gurjinder Singh wants to know what is the role of C squared in the energy and mass equivalence formula?
Please repeat.
Why the speed of light is being squared in the mass energy equivalence formula?
This question is by.
Gurjinder Singh.
All right, that's a great question. I would like to appreciate it. Now I expect him to know some basic math. So now see, when something is moving 4 times at its rate, 4 times faster, it doesn't have that much energy. It gains energy of 16. 4 fours are 16 similarly. So light is squared so that we have combined mass and energy together. And that's the reason mass or energy increases when the speed of light is squared. Another question. I guess we can accommodate only 2 questions in the remaining time.
Yeah, the questions are over. So
All
I
right.
was
Yes,
posting
yes.
the quiz link soon in the chat box, so you can also attempt the quiz after the webinar.
Before that, I would like Tejas to give some instructions.
Okay, all right. So as we discussed already about this is about the game of energy, and we are here to discuss about the game of energy and all that stuff which Anushka you just shared. Now we will be sharing the quiz link, and it will be link of Google Forms, and quiz and feedback option will be there already. You just have to click on that link and type the answers, and mostly MCQs are there. You have to click the right option and that only. All right.
Yes. Before that, Priyanshu messaged that many questions are not answered. Now, from the starting of session till now, there might have been 50 to 60 questions. So, is it possible for me to answer all of them? It's not possible. It might take an hour to explain or to answer all those questions. You ask questions just on the basics you know. But in order to make you understand certain thing, sometimes I need to explain each and everything in detail. So I asked my coordinator to take out the best questions. Some members have asked questions not related to this topic. Now, this doesn't mean I am not willing to answer those questions, but what I mean by that is you should ask questions related to webinar because we have conducted the webinar related to energy. Yes, I agree some questions are not answered, but with the reason. It's not possible to answer 50 to 60 questions. And as my coordinator, as my friend Tejas said that he is circulating the form, I hope you feel that properly. And yes, I hope to see you in further webinars with Exploring the Cosmos with this great group that took an initiative to call me in their group and gave me a platform to explain you all about the energy ranging from planet Earth, ranging from universe and beyond. Yes, thank you
Okay,
everyone.
so okay, all right. Akash have sent the quiz link. It is actually the Google Forms. We have to click on that link and we have to fill the quiz and feedback
And
and
Tejas, make
responses.
sure you put that link on the YouTube as well because some of the participants have joined there.
Okay, all right.
Yes, thank you. So
Okay, so here
yes, I would
our
like to thank everyone for joining this session, for asking interesting questions. And though I wasn't able to answer some questions, I'm sorry for that. And thank you for joining. I really appreciate all those members. I admire them. It's been a great response. This was our first webinar conducted by Exploring the Cosmos group. As the link is mentioned in the chat box of Zoom, make sure you fill that form. It's not very lengthy one. And my friend Tejas is also putting that link on the YouTube comment box. So the members who have joined this session on YouTube can join over there. Yes, thank you everyone. I am glad to have you all here.
Okay, so our
Okay, guys.
webinar
So
is
here the web. What?
Hold on,
Okay. You.
yes, we haven't done yet. Please wait.
Yeah. Yeah. All right.
for the members on Facebook. I don't know what is happening on the comment section of that Facebook live stream. That link is not opening and it is not working properly. I'm sorry for that. But those who have joined our Zoom meeting can access that link and can fill that form.
It has also been posted on YouTube.
All right, thank you.
So we should end this webinar here.
Thank you everyone for joining. And if your friends or family members were willing to join this session but weren't able to, make sure you share the YouTube link with all of them. And I am expecting a huge response, though this session has ended. Thank you everyone for joining us. Thank you once again.
Okay. Thank you. This webinar ends. And also note that this webinar was the first by Exploring the Cosmos group, which we recently organized. And we are the coordinating team, which we are still newbies. We don't have any experience in conducting webinar. Although it's been more than 6 months for our Exploring the Cosmos group. So if you notice any misinformation or any lag or any glitch between the webinar, please ignore us and we will be grateful for that. Yes, Rita Ahmed, we will uh, take more webinars in the future. Okay, so thank you guys. I hope you have filled the Google Forms and have played the quiz, and then you have given the feedback about this webinar. So I'm ending this webinar. Thanks, everyone.
Yes, thank you.